Okay, so as said, I'll present an overview very briefly of what HIWeather is, and then in particular what the predictability and processes team within HIWeather does and what the goals are of this theme. So, as you may know, HIWeather is one of the 3 core projects of WWRP, which is the World Weather Research Program of the WMO. Research in HIWeather is organized into 5 different themes, and 4 of which have already presented a seminar here. And today it's the theme Predictability and Processes that is hosting this seminar. HIWeather has a mission, and that mission is to promote cooperative international research to achieve a dramatic increase in resilience to high impact weather. Hence the name. So HIWeather stands for high impact weather. So it has a clear focus on that. And how do we attempt to do it? First, by improving forecasts for timescales of minutes to 2 weeks. So basically ranging from nowcasting to what is usually perceived as the limit of predictability of traditional weather forecasting. And second, and at least equally important, is by enhancing the communication and the utility of these forecasts for social, economic, and environmental applications. So Brian Golding, one of the co-chairs of HIWeather, has sort of come up with an illustrated schematic to illustrate the scope of HIWeather. So if we look maybe 100 years back, how would people make decisions in the face of severe weather coming up? So they would probably look at the sky, maybe see a storm coming, and then decide to seek shelter or to change the course of their ship. Nowadays, fortunately, we are in a more we have come a long way, and we are in a much better situation. We have quite some ability to forecast the weather, but not only the weather in the sense of the atmospheric state, but also the hazards that may develop from that, say, flooding, and now also increasingly then the actual impact that this hazard will have, because not all hazards have the same impact all the time. So we come a long way in terms of forecasting, but then these forecast products may be fairly complex, and stakeholders may have specific needs. So to communicate the information from the forecasts, it's very helpful to have experts that give out warnings. And then the way the warning is phrased will actually have impacts on how decisions are being made. So this is what we call the warning value chain, because each of these mountains that you see here sort of, they add value to the chain of events that lead to a warning. The predictability and process team is basically situated in the left-hand side of this value chain, basically in the traditional business of weather forecasting, using observations to improve forecasts, to improve process understanding that then would lead to improved forecasts, and also bridging over to forecasting hazards. So the goals, of course, are improving knowledge and understanding of the processes that underlie weather-related hazards, so as to assess their predictability, and then eventually improve forecasts, which are the meteorological source sort of for the warning value chain. HIWeather has, well, of course, a focus on high impact weather, but they're a focus on specific hazards, and it's a broad range of hazards that you can see here. So it ranges from urban flood, urban heat and air pollution, to wildfires, extreme local wind, and disruptive winter weathers. So with that, I now come to our predictability and processes theme, and here, in the briefness of time, I just can give you sort of flavors of what we do there. So on the one hand, we do study predictability of mostly individual cases, for example, using operational ensemble forecast systems. So this example here is from a windstorm that affected Northern Europe in 2015. blue box and whiskers that you see on that plot basically give you the ensemble forecast distribution of 24-hour wind gusts. The initialization time sort of goes from left to right. So to the right, the forecasts are initialized closer to the actual event, and the event verifies with that star in the right-hand upper corner. And the red box and whiskers, they are climatological distribution of the gust forecast. So how we can interpret that is basically the ensemble system definitely gave us a heads up on this event. If you look at the initialization times closely, maybe something like a week ahead of the event. Another result here would be that the ensemble underestimated, at least in a not post-processed way, the magnitude of the event. So this is basically diagnosing the predictability characteristics in operational models. You could go for individual cases a step further and not only look at the predictability characteristics, but also try to link them with the dynamics, at least as seen by the forecast model. So this is again an example using the operational ECMWF ensemble forecast system. The sort of ensemble distributions are given in the lower panels, where the height. So this is for the tropical transition case, so a hurricane formation by a specific pathway of Hurricane Chris in 2012. So the height of the bars in the lower panel show you the number of ensemble members that form any cyclone, and the colors then denote whether it's sort of a cold core cyclone, so whether the forecast system thinks this one will be an extratropical storm, or whether it goes tropical, which is then the red, the warm core systems. And then in this study, we try to link these ensemble statistics with say how well precursors of the system were represented in the model using basically ensemble sensitivity methods. Another line of work would look at, say, parameter sensitivities in numerical weather prediction models. So this is a study that did a comprehensive sweep of the phase space of uncertain parameters, not only so for microphysics, that is, but not only the microphysics uncertainty, but also how that uncertainty relates to uncertainty in the environment. And I think that's an important thing to do. If we talk about sensitivities, then we should all first look at the most important sensitivities. And so this is actually a study for an idealized case. And I don't want to go much into details here, but we could see, so this is for precipitation characteristics, and the bars on the right-hand side, they show us how sensitive production of hail basically is, and there we do see fairly significant dependencies on how exactly cloud condensation nuclei or ice nucleation particles would be represented. But said again, that's only for one idealized case, and specifically for a convective cell that is initiated by a cold pool. If you look at other initiation mechanisms, the sensitivities could look slightly differently, and if you use another ice microphysics theme, then your sensitivities may look quite different. So this is basically predictability studies in a case study framework. The second flavor sort of that we have in the task team is that of field campaigns. So HIWeather does not conduct the campaigns themselves, but we have representatives of these campaigns, and of course the campaigns provide crucial observations for process understanding. And or we take, and so if the campaigns are still in the planning phases, ideas of HIWeather are taken into account into the planning, or at least considered in the planning phase. And so you might see that the ranges here are also very strong range from geographically from the North Atlantic to South China to Argentina, and process-wise going from severe precipitation to boundary layer variability that is important for convective initiation. So there's actually quite a challenge here, and that is the broad scope and the fragmented communities that need to come together to work on these topics. So that's actually something that the implementation plan had realized of HIWeather for the project in general, but it's particularly true also for the predictability in processes theme. So the very diverse set of weather of the focal hazards are related to very different weather systems, and our sort of the atmospheric dynamics predictability community tends to cluster around specific weather systems. So it's hard to integrate work based on these focal hazards. The same is sort of true for the multitude of the relevant processes. So usually communities revolve around, say, the microphysics, so that the cloud community is a big one. And then we have turbulence communities now, maybe also considering the urban canopy here, and I didn't even mention atmospheric dynamics here, which is again a different community. And scales are vastly different too, so it's hard to integrate based on these more common ways to forge collaborations. And what is important for me here to mention is that if we want to understand the weather system that lead to high impact events, we may not only study the high impact events, but we need to understand the governance processes of the regular events too, so that we have the opportunity to actually compare and then understand what makes it high impact or what makes it particularly severe. So there is a lot of expertise that we bring together here in that theme, but the question is how to synthesize and how can we make form something that is bigger than the sum of its parts, basically. So there is hopefully a way forward, and this is through key activities that HIWeather has recently started. And if you're familiar with the HIWeather workshop, it's 3 activities that actually form the content of the workshop that will start next week. So it's basically successful citizen science, a warnings value chain, and something called towards the perfect warning. And I'll talk a little bit about what it is in a second. So the workshop on successful citizen science, it's a broad theme that encompasses the full value chain, but it does include also the use of what people tend to call unconventional observations, sort of everything that is low quality because it comes from low cost sensors, for example, mobile or in mobile sensors or windshield sensors in automotives, or from social media. But the good thing is there's a lot of that. So there's a lot of data, though low cost. There should be some value in actually using it, and Calvin Alkin's talk is in that context, as he's using social media data to identify hail-producing storms. Then the second key activity is, its full name is actually the end-to-end evaluation of the value chain. So I've introduced the idea of the value chain earlier, but this chain has not been evaluated end-to-end in the sense that it's not well known how well the flow of information is, at which part of the value chain most of the information is lost, how for uncertainty, for example, is treated, uncertainty information is treated. So this will be one of the key activities, and in doing so, or as part of this activity, a catalog will be compiled that encompasses lots of cases, so metadata for these cases. And my hope is that people would use this catalog and this assembly of many cases to try to do, say, meta studies, to learn something that goes beyond individual or just a few case studies. And Linus Magnussen's talk is in the context of this key activity. And finally, there's a book being written with the name Towards the Perfect Warning Chain. And the main theme of this book are partnerships to bridge the gaps. So those of you who have seen the value chain schematic a few times maybe have been asking themselves, where are the bridges? There they are. So the idea is that the mountains, this is expertise that sits in specific communities or maybe in specific agencies and institutional bodies. And when these communities, institutional bodies need to communicate, there may be some friction, there may be a way. So information may be leak out during passing from one mountain to the other. And the partnerships present the bridges that should help to lose as few information as possible. And here in our context today, Rob and Peter will talk mostly about observations and how process understanding or predictions can be improved. And with this, sort of with this lineup that also serves as the list of the following talks, I'll be ready to take questions and comments.
So far, no real questions for you, Michael, but maybe our speakers have questions.
Okay, so if this